So the scattering matrix describes how the output port looks like if we decide an input port profile. But transmetric matrix, we are trying to describe the profile from one side and its relation to the second side. So usually this is one input and one output. For scattering, it is all output from one side and all input from one side. But for scattering matrix, it is more geometrical speaking. We are trying to make the junctions, the vectors of the same port together into a new vector. Then, if we have a two cavity or two systems consecutively linking to each other, then we can write it down that A1B1 as a transmetric 1 times A2B2. And A2B2 is a transmetric transformation of A3B3. So the transmission matrix as a whole will be just a direct multiplication of each one. Okay, so let's see what the transmission matrix like for the two cases again. So similarly, in this case, what will be the T11? So T11 will be the ratio between A1 and the A2 if there is no B2. Okay, let's see. If there is no B2, so there is no B2. The ratio between A1 and A2. So obviously it is transmitted. So when you write down like this, so when A2 divided by A1, it will be 1 minus 1 divided by T11, the first matrix element. And the physically speaking, it should be T. The similar case, if the B2 is equal to 0, B1 will be T21 times A2. And this is the reflectivity. So we have the minus R to be B1 divided by A1. Okay, so what does B1 divided by A1 mean? That means we need to divide the A2 from both sides. We will get T21 to T11. So this is just a mathematical sheet. You can just see 1 more 2, 3 times. You will know what it is. Probably you already know what we are doing here now. So secondly, we can also try to let A1 to be 0. A1 to be 0. That means there will be no input from the left-hand side. So the ratio will be only between B1 and the B2 and the A2 between B2. Okay, so you will simultaneously get a relation between I and T with the T21 and the T22. Okay, so after rearrangement, you will get the four elements as follows. T11 is 1 divided by T. T12 is minus R divided by T is equal to T21. T22 is T plus R squared divided by T. And if it is lossless, then it will be T over T squared. And the T squared plus R squared is equal to 1. Yeah, most of case we will just assume it's lossless, but not necessarily. It could be, it could have some loss. That means some power reflect here, some passing through, and some dying in the middle. Yeah, so that will be absorption, but that's the result. So the more correct way is writing it down like this. But if it is lossless, it will further reduce into 1 over T. Okay, so now the transmission matrix of the interface could be written as 1 divided by T times because we can pull the 1 over T out of the matrix. 1 minus R minus R. We also do similar thing. between for the homogeneous medium. So it's all the same figure, but we only change the notation. This is A1 from lower AA1 as upper letter AA1. And at the right hand side, this one original B to be B1, but since we are discussing what happens in the interface 2, so it's now become the A2 and the B2 and the B1 as well. So first, let's assume B2 to be 0. If there's no input here, then T11 is the ratio between A2 and A1. And the T12 is the ratio between B1 and the A1. Yeah, so it will be 0 because we don't have input from the right hand side. The other case is we can assume B2 is 0. Or we assume A1 is 0. Oh, okay, yeah, B2 is 0. So we can assume A1 is 0, no input here. We will also get the T21 to be 0 and the T22 to be exponential minus J beta L. So the transmission matrix is a matrix like here. Yeah. So it's non-zero at the diagonal. At the diagonal, but it's all 0 at the other end. So we have the scattering elements with R11, T21, R22, and T12 intuitively. So how do we map the S with those T? So first, the first column, let's assume B2 to be 0. So it's 0 here. So that will make the A1 to be A2 times T11, and the B1 to be A2 times T12. Okay. Then we can divide the both terms. So in the right hand side will be T11 okay, so let's do that. So I should shift the okay, that doesn't matter. So if B1 is T21 A2 and the A1 is T11 A2, that's when assume B2 is equal to 0. Then B1 over A1 should be T21 or T11. And this obviously should be the reflection in the first floor. So it's physically equal to R11. And R11 equal to S1. Okay. So we can just build it column by column and row by row. Second, A1 will, if B, since A1 is T11 times A2, simultaneously we assume B2 is 0. So the T21 will be 1 divided by T11. Okay, so this is the relation T11 to the T21. And the T21 is S21. Third, let's assume there is no, when A1 is 0. A1 is 0 means there's no import from A1. So this is 0. So in this case, 0 will be T11 times A2 plus T12 times B2. And after rearrangement, we will, because the R22 is the difference, the ratio between B2 and A2, then we make a rearrangement. The R22 will be minus T12 and the T11. Finally, if we compare the left side, if A1 is 0, A1 is 0 means that A1 is 0 here. And then we see the second column. B12 divide is equal to T21 A2 plus T22 B2. Okay, then we divide the B2 at both sides. it will be T21 times A2 divided by B2 plus T22. And A2 divided by B2 can be found here. And what is it to replace A2 and B2? So you get the T12 will be T11 times determinant of T. So it is T11, T11, T22 minus T12, T21. Okay, after some algebra. Alright, so now we can match this 4 value of this 4 instead. So the X matrix now is written as 1 over T11 times the X21 becomes T21. The S12 becomes determinant T. And the S21 is 1. And another minus T12. So if a system is reciprocal, in our previous statement, the system will, if this scattering matrix should be symmetric. So for a lossless system, its transmission matrix, its determinant need to be 1. Okay, so this is the conclusion or the mathematical characteristic for a reciprocal system. Its determinant need to be 1. Second, if a system is lossless, in the scattering theorem, we said that the moduli of a direct column, its sum need to be 1. So it will be T12 over T21 squared plus T11 1 over T11 squared need to be 1. So it should be T21 plus squared plus 1 need to be T11. So that's the characteristic of a lossless system in the transmission theory. If both, that means it's reciprocal and lossless. So that means in the second row, T11 times determine T divided by T11 squared plus T12 divided by T11 squared should be equal to 1. And since T21 plus 1 should be, since determinant need to be 1 for a reciprocal system. So it means 1 plus T12 squared. Write it down. T11 that squared plus T12 T11 squared need to be 1. And since this system is reciprocal, this need to be 1. So it will be T11 squared, that is 1 plus T12 squared need to be 1. Okay, so 1 plus T12 squared should be T11 squared. And since it's simultaneously lossless, it will be 1 plus T21. So the conclusion T12 squared should be T21 squared. Okay. So actually you will find out that it's T11 and the T12, it should be T11 should be conjugate of T22 and the T12 conjugate of T21. So this is it will be Hermitian symmetric. Yeah, from the diagonal direction and off diagonal direction both. And a combination of reciprocal system will be still reciprocal. This is proven by math. Because if the system 1 is reciprocal, means its determinant should be 1. Similar for 2. And the combined system, delta 1, will be delta t, will be delta t1, t2. And according to the linear algebra, it will be delta t1 times delta t2 is still 1. So a combination of a reciprocal system is still reciprocal. From scattering matrix, we find that a combination of a lossless system is still lossless. So this the both word lossless and the reciprocal, it has a property of combination.